Okay, this is going to be a vodcast on some exceptions to electron configurations for certain elements. There's a few number of elements that don't follow the electron configuration that was taught initially. Um, for me, I first teach them all how to use them all, and then go back and teach the exceptions. So there's a few that don't follow it. So let's take, for example, and I'm just going to do, at least for my students, they have to know these ones. And let me highlight them on the periodic table. So chromium, molybdenum, copper, gold, silver, and gold. So for my students, you have to know these 5 elements. There's definitely going to be more elements that don't follow the electron configuration rules, but I think this is pretty straightforward and easy to learn. If you just know these 5 elements, you'll see why. So let's tackle the first one, chromium, why it doesn't follow it. So chromium, I'm going to use shorthand notation to discuss this. So AR. So I would originally written 4s2 and then a 3D 1 2 3 4 3D 4. So that would be the way it was probably taught to you and how you would write it. There's an exception to this, and the exception is it's got this one. It's got a 3D 4. If it's a 3D 5, that's actually more stable. So one of these electrons will actually go and become a 3D 5, and you'll end up having a 4s1 instead. So this is the way it's supposed to be, I guess, according to how it is. But the real chromium that you have to write is going to be AR 4s2, I'm sorry, 4s1 3d5. And this is what's been observed, through experiment, showing that this is a much stable electron configuration than the one on top. So whenever you write the electron configuration of chromium, you have to write this one. Do not write the one on top, because the one on top, it would really technically be incorrect. And this is, again, based off experiment and observation. Same goes for copper. Copper is another element that does not follow the electron configuration because it's got a little more stable one. So when I do copper, the actual copper, it's going to be a 4s2. Whoops, I forgot to put the noble gas. So AR is my noble gas. Gotta make sure I follow my own conventions here. So 4s2, and then it's going to end in technically a 3d9. Okay, but that is not what is observed through experiment and observation. What they will see is it's going to be a copper. Again, that one electron from the 4s will carry down, and it's going to be a 4s1 and in a 3d10. And that is a more stable element than the one on top. So this is the one you would have to memorize. So these are a few of the exceptions. And if you notice that molybdenum is going to be very similar to copper, except it's lower on the periodic table. Same with silver and gold. So as for me anyways, those are the elements that you need to memorize that will not follow the electron configuration that is originally stated. You have to write the exception to it. There's several more elements, and as you go down the periodic table to the lower elements, they start to get a little bit funky, and we will not be going over those, or nor will you be responsible for them. Just these 5 elements for my class. So just bear these in mind. You're only remembering 5 elements, and it's basically the D4s and the D9s, and they will not follow the electron configurations. And I think it's pretty straightforward and easy to remember.